So let's take a look now at a number called e. This number appears a lot in mathematics from here on out. So let's examine this expression, 1 plus 1 over n, all to the nth power. So you'll notice that we are to use our calculator to approximate this expression for various values of n. And these values of n are increasing. And the last one we will look at is whenever n is equal to 1 billion. So let's type into our calculator this expression. So in the first one, I'm going to go ahead and show you how to do this on your calculator. You're going to put a parenthesis, 1 plus 1 divided by 1 raised to the first power. Now obviously this is just going to be 1 plus 1, which is 2, raised to the first power. And so our answer is just going to be 2. What happens if n equals 1,000? Again, in our calculator, we will put 1 plus 1 divided by 1,000 raised to 1,000. And this yields for us, and we're going to use as many decimal places as our calculator shows, 2.716. Now, your calculator may show more decimal places than mine or less, but we're just going to list them all. 2.7169, 23932. So I suggest pausing the video if you obtained both of those, and now seeing what happens whenever you put in 1 million for n and then 1 billion for n. So what do we get? We get, if n equals 1 million, we obtain 2.718280469. Now notice this number that we just obtained is only slightly different than the number that we had obtained previously. Well, what happens if n equals 1 billion? We obtain 2.718281827. And these, of course, go on. So, notice the similarity between this number and the number previously. It seems to be leveling off, as it were. So if n gets bigger and bigger, what happens to this expression? And that is what we call the number e. So as n approaches infinity, it will approach some number, and we will call that number e. So notice that e is about 2.718281828, so on and so forth. And it never stops. It never repeats. So this is a number quite like pi, in the sense that it never terminates, it never repeats. Square root of 2 does the same thing, but e is even more like pi. So let's use this number. So a good thing to remember is that it's just under 3. So it's about 2.7. So we can use our calculator to approximate 137 e to the 2 pi. So where do we find the e button on our calculator? So on most scientific calculators, the place to find our e button is near a button, or related to a button called ln. So if you'll notice, right above the ln, we see this e to the x. So to access that, we will type second e. So in our calculator, we will type 137. Then we will press, and I'll make this a box so that you can tell it's a key. We're going to press times. Then we're going to press second. Then we have the ln key. And the ln key has our e to the x above it. And then we're going to use a parenthesis. Then we're going to press 2. And then pi is right under the ln key, so we can press pi. And then we're going to close our parenthesis. And then we will round to 3 decimal places. So 137 e to the 2 pi is about 73,362. And then we have the decimal places 3, 5, 6, 8, and so on and so forth, but we just round to the third. So the 8 makes us round up, so that 6 will become a 7. And again, you will notice we're using the approximation symbol because this is our exact and this is our approximation. So 137 e to the 2 pi is approximately equal to this quantity on the right. So now let's take a look at how to use this to graph. So since e is just a number, remember that we have our graph y equals a to the x, and that's increasing if a is bigger than 1, and it's decreasing if a is less than 1. So if a is bigger than 1, it's increasing. But here, what's a? Our base is e. Notice that e is about 2.7, which is bigger than 1. So our graph will be increasing. So y equals e to the x will look like what? We have 0, 1, we have 1, e, and we have negative 1 over that. So negative 1 over e will be between a third and a fourth. So you can't really tell in a graph, which is nice, unless we got really close. And then we have a horizontal asymptote. And this is, again, not the graph that we're looking for. This is the parent function. So what we're going to do now is we're going to use the transformations. So we have this division by 2, and we have a subtraction of 2. So the division of 2 is going to be a horizontal stretch by a factor of 2. And then the subtraction of 2 is going to move us down 2 units. So instead of instead of the x-axis, y equals 0 being our horizontal asymptote, we will now move that down. And so let's look at our key points. So let's look at 0, 1. If we stretch it horizontally, it will not move. And then we'll move it down 2 units. So we'll be at 0, 1 for our y-intercept. And then 1, e will be will be stretched by a factor of 2. So it will be 2, e, and then move it down 2 units. And then likewise with our point 1, 1 over e. Will be stretched horizontally and then shifted. So our graph will look like this. Okay. So now what's the domain? The domain is negative infinity to infinity because it's an exponential function. The range will be from negative 2, or horizontal asymptote, and then upward. So negative 2 to infinity, and we don't include the negative 2. Our horizontal asymptote is y equals -2. And then what about our y-intercept? It's clearly on the graph to be -1. Now, if it were not so easy to see, we would just put in 0 for x. So f of 0 would be e to the 0 minus 2. So e to the 0 is 1, so we'd have 1 minus 2, which is -1.